Okay, let's look at some actual applications of integration by substitution. So it says some food is placed in a freezer. After T hours, the temperature of the food is dropping at the rate, a derivative of R of T degrees Fahrenheit per hour, where R of T equals this big old bad boy. Compute the area under the graph. So that means to do this from 0 to 2. And then what does it mean? What do you mean? So I put this information here, dt. Now I probably would separate these, meaning 12 dt plus, and then the other piece, 4 over t plus 3 squared dt, because this way now I can look at each piece individually. So the piece on the right is the issue where I'm going to have a substitution where I'm going to let u equal t plus 3. So the derivative, doing my substitution side, would be 1 dt. So where I see dt, I'm going to plug in du. So continuing back over here, I'm going to have from 0 to 2, 12 dt plus from 0 to 2. The 4 stays there. The t plus 3 becomes u, and then of course I have squared, and then du. So now I can do all that crazy stuff that we do. The antiderivative of 12 is 12t, and from 0 to 2. Plus the antiderivative of this business, well, if I bring u squared to the top, this actually becomes 4u to the negative 2. So I'm going to do that whole crazy stuff that all them kids are doing these days, right? The antiderivative would be 4u to the negative 2 plus 1 over negative 2 plus 1. And I'm evaluating that from 0 to 2. So then all I have to do is 12t from 0 to 2 is just be sure and plug my u back in, right chair. But what I'm going to do is I'm actually, let's take you right there and erase you. I am going to take this negative 1. What the heck is that? I'm going to take this negative 1, because negative 2 plus 1, and that's going to end up being a minus sign. So minus 4, and u to the negative 1 would go to the bottom, right? Well, let's go ahead in the same step where I see u, plug back in t plus 3. So from 0 to 2. So all I did was I brought the negative 1 up, so that made this negative. I brought u to the negative 1 to the bottom, so that just becomes u, and then I plugged u back in. And so from here, now you're home free, meaning that you would do your fundamental theorem of calculus where you plug in 2, and then you plug in 0. So that is just this piece. And then minus, plug in 2, minus, plug in 0. Okay, so that's all your nice little pieces, and you should get approximately 24.53 degrees Fahrenheit, which that area represents the temperature of the food at the end of 2 hours. All right, next, trash you. After 2 hours, a drug is slowly leaving the body at a rate. Well, then that looked funky. This is just supposed to be ln of x, so ln of x over x. What is the amount of drug between 2 and 10 hours? So this is going to be a substitution. What I always say is sometimes it helps to actually separate these, meaning ln of x times 1 over x dx. You can do that, right? You know that, right? Right? So in other words, I just separated this into 1 over x, because now I can see that if I let u equal ln of x, du equals 1 over x dx, which is exactly that. And so that piece becomes u. So plugging things in, I get 2, 10. I'm looking here, ln of x is u. 1 over x dx is du. Antiderivative, u squared over 2 from 2 to 10. Plug u back in, which is ln of x squared. And then finally do my f of b minus f of a, ln of 10 squared minus ln of 2 squared. And I throw that in a calculator, and somewhere I get 2.41072, and this is milligrams. So that's the first two questions.